use 3 rules today for numerical integration. So this is when we use numerical integration when, nothing else doesn't work. We can't split it up. We can't use substitution. We can't use integration by parts. We have 3 rules that we can use, and I'm going to walk through those rules and kind of get the first one started, and then we'll work some more when we're together. All right, so this is numerical integration, midpoint rule, trapezoidal rule, and Simpson's rule. So midpoint rule is using midpoints. So what we're going to do is, so this formula says if I'm integrating from a to b f of x dx, then we know that the midpoint rule that we used back in chapter 5 is finding the midpoint, right, of each of those rectangles that we added up, and then multiplying them by their width. And so that's this formula. So we'll use that midpoint rule. So I have to find like f of 1, and so this is my first, this is my first x value, and then my second x value after we've created those subintervals. All right, so first of all, my b minus a over n, or the width of my subintervals, I need to find that. And so b minus a over n, over 4, we're going to do 4 subintervals, is 1/4. All right, so now I'm going to use this formula. Remember, this is from a to b, that's where I got those numbers. So this is my delta x. And then I'm going to plug in values. So I'll plug in, f of 1/4. F of 1, starting with the first one. Plus, I'm going to add 1/4, so 1 and 1/4, so that would be 5/4. Plus f of 5/4 and 1/4 is 6/4, that's 3/2. Plus f of 6/4 and 1/4 is 7/4. Plus f of 8/4, which is 2. And that's where I'm stopping because that's my b. So I started at 1, and I just added 1/4 to those. All right, and then I'm also multiplying that by delta x, which is 1/4. Not delta, sorry. Yeah. So the b minus a over n, that's delta x. So I'm going to multiply it by that. Now I'm going to go evaluate in my function. So I'm going to plug in 1 to my function and square it. So that's 1 plus 5/4 squared is 25/16 plus 3/2 squared is 9/4 plus 7/4 squared is 49/16 plus 2 squared is 4, and then multiply that by 1/4. And then we can just throw that on the calculator and get an answer for that. All right, so that's the setup on that one. All right, trapezoidal rule, a little bit different. So in their formula, they're using y naught instead of f of x sub 1, f of x sub 2, f of x sub 3, and all the things. All right, so the difference between this one is there are coefficients on the inside of this for my y values. There are 2's all in the middle. So remember trapezoidal rule, when we line up those trapezoids, the first one isn't repeated, but the second one is the right side of the trapezoid, the first trapezoid, and it's also the left side of the second trapezoid. So that's why there's a 2 there. All right, and then this just tells me I'm starting at A and I'm stopping at B. All right, and then my delta x is b minus a over n. So if they tell us 4 subintervals, we'll do the same thing and evaluate. So if I'm doing the same function and I'm going from 1 to 2 x squared dx, I'll switch for the next one, and I want 4 subintervals, then I already know that my delta x is 1/4. We did that on the last problem, b minus a over n. And then I'm going to plug into this formula. So the trapezoid formula says delta x divided by 2. So 1/4 divided by 2, which we know is 1/8. I'm going to move down here because I don't like that layer fractions. So this is delta x over 2. All right, so 1/8, and then I'm going to go plug in. This is going to be when x is 1. This is going to be when x is 5/4. And then I'll just do mine for this one. All right, so y0 plus 2y1 plus 2y2 plus 2y3 plus y4. And I'm stopping there because we wanted 4 subintervals. So this is when x is 1. When x is 2, I need that y value. When x is 3. When x is... What am I doing? I'm not counting by fourths. I'm sorry. Probably wondering what I'm doing. I meant first x, second x, and I wrote down that. All right, so my first x is 1. My second x is 1 plus 1/4. My third x is 5/4 plus 1/4. My fourth x is 6/4 plus 1/4. So it's 7/4. And then my last x is 8/4, which is 2. All right, so those are the values I'm going to plug in. Why the trapezoid rule doesn't look like the midpoint rule, so we could just have f of 1, f of 5/4, f of 3/2. I don't know why. All right, so we plug those values in to this function, and we get our trapezoidal rule. So I have 1 plus 2 times 25 over 16 plus 2 times 36 over 16, or 9/4, I guess. I don't know why. I have 6 over 4. All right, so 9 over 4 plus 2 times 49 over 16 plus 2 times 4. Oh, no, sorry, there's no 2 there. What am I doing? So just plus 4, sorry. All right, and then I can add all those up and approximate it, and then we can compare it to the actual value. All right, last one. By the way, comparing to the actual value gives us the error analysis as well. All right, so Simpson's rule is a little bit different. So we have delta x over 3, and then all of our y. So notice the coefficients, 4, 2, 4, 2, 4, 2, 4. And n has to be even to do this. So we're always going to choose an even number of subintervals for this. All right, so let's say we're going from, I'll try to make this one quick, and go from 0 to 2, and let's go 5x to the 4th dx. All right, so my delta x is 2 minus 0. We're going 4 subintervals. So my delta x is 1/2. Right, so trapezoidal rule for, Simpson's rule for this would be delta x over 3 and then y sub 0 plus 4y sub 1 plus 2y sub 2 plus 4y sub 3 plus y sub 4. All right, so I have 1/2 for delta x divided by 3, which is 1/6, and then I plug these into my function. So this is going to be when x is 0, when x is 1/2, when x is 1, when x is 3/2, and when x is 2. So I go back, plug it in here, and then go from there. So I have 5 times 0 plus 4 times 5 times 1/2 to the 4th plus 2 times 5 times 1 to the 4th plus, and you can see how that continues on, and then throw it in your calculator, or just simplify it from there if you want to leave it as fractions. All right, we'll talk about the rest when I see you.